Okay, pre-calculus students, we're still working on Unit 8, which is our exponent and logarithm unit, and we're working on Day 1 notes. We're now on page 3. We're going to continue working on odd problems. So on this page we'll have 23, 25, 27. So if you have an exponential equation, the only method we've learned so far is to get each base to be the same number. So 8 and 2 can both be powers of 2. I'm going to change the 1/8. Now I know 2 to the third is 8. So if I want 1/8, I'm going to do 2 to the negative 3 because the negative exponent puts this number in the reciprocal, so in the denominator in this case. And I still have raised to the x power. And then I have 2 to the x minus 6. If you have a power to a power, you want to multiply those exponents, so you get negative 3x. And then once your bases are the same, you can disregard them and just deal with the exponents. So you know that negative 3x has to equal x minus 6. Subtract x from both sides. Negative 4x equals negative 6, and then divide. So we get x equals 1.5. Alright, on the next one, I see powers of 3 here. Remember that a square root is the same as an exponent of 1/2. So 3 to the 1/2 is the same as square root of 3. And then there's your x plus 1. And here's your 3 to the x minus 1. So this 1/2 has to distribute to the x and to the 1. So I have x minus 1 equals 1/2 x plus, and 1/2 times 1 is 1/2. Alright, next I need to get my x's together. So I'm going to subtract 1/2 x. That will cancel these out. And a whole x minus a 1/2 x is a 1/2 x. Minus 1 equals 1/2. And then add the 1. So we get this 1/2 x. These cancel. And 1 is the same as 2/2, so 2/2 plus 1/2 is 3/2. So I have 1/2 x equals 3/2. And if I multiply by 2 on both sides, that will cancel this out, and that will cancel this out. So I get x equals 3. Alright, this is also powers of 3, so 9 is 3 squared. And then there's your 3x. 27 is 3 to the third. And that's your x minus 2. So you're going to raise a power to a power, and you have 3 to the 6x equals 3. And distribute, so you get 3x minus 6. Now the bases are the same, so I can say that the exponents are the same. Subtract the 3x. So 3x equals negative 6, and dividing it by 3, x equals negative 2. Alright, 29. Again, I'm going to write the 9 as a power of 3, so 3 squared. And there's your x plus 1, and you have 3 to the x equals. So distribute your 2, and you have 3 to the x equals 3 to the 2x plus 2. And then you can set your exponents equal. So x equals 2x plus 2. Subtract 2x. Negative x equals 2, so if you divide by negative 1, you get x equals negative 2. Alright, let's try the domain problems on the last page. Alright. So a logarithm function is the inverse of an exponential. And remember, the exponential function will have a horizontal asymptote at y equals 0. So the logarithm has a vertical asymptote at x equals 0. And the graph can have any number as an output, but for an input it has to have a number greater than 0. So you take this part right here, the argument of the logarithm, and you set it greater than 0. So in this case, x is greater than -3, and you can put that into set notation by saying all x such that x is greater than -3. 33 is a logarithm of a quadratic, and so you're going to need to make a number line and test points. So x squared minus 1 is x plus 1, x minus 1, and that has to be greater than 0. So my key points are -1 and +1. Alright, less than -1, between -1 and 1, and greater than +1. You plug them into the factors. So -2 plus 1 is negative, -2 minus 1 is negative, so negative times negative is positive. For the 0, I have positive times negative, which is negative, and if I put in the 2, I get positive times positive, which is positive. So these numbers are in the domain and not these. So I can have negative infinity up to -1, not including it. And then +1 to infinity. Okay, and that is the end of the 3rd and 4th pages of your Day 1 notes.